Hi students, welcome to Sunil's tutorial. I'm Sunil Mirwani and today we'll be doing the sums of electrons and photons. Read down next sum please. The radiation of frequency 8 into 10 raised to 14 Hertz is incident on a metal. The maximum kinetic energy of the photoelectrons, is 1.5 into 10 raised to minus 19 joules. Find the maximum kinetic energy of the photoelectrons. Find the maximum kinetic energy of the photoelectrons when a wavelength of 4500 Armstrong units is incident on the metal. Now here, let us assume, let V0 be the threshold frequency. Now I can say that max kinetic energy is going to be equal to nothing but hv minus work function, right? So max kinetic energy is going to be hv minus hv0. Thus you could say that max kinetic energy is equal to hv minus v0. Therefore max kinetic energy upon h is equal to v minus v0. Therefore V0 is equal to V minus max kinetic energy upon H. That will give you the threshold frequency. Once you have the threshold frequency, they give you that wavelength of light that is now incident on it is 4500 Armstrong unit. So you can find out the frequency of light. I can say that V2 is nothing but C upon lambda 2. I know I'll find out the frequency, incident frequency, velocity of light in air. We know is 3 into 10 raised to 8 meters per second. And lambda 2 is already given to you, wavelength of light is given to you. So in that case, I'm going to ask you to find out, find the maximum kinetic energy of the photoelectrons. Ke max. Max kinetic energy is nothing but hv minus work function. So max ke2 is hv2 minus hv0. v2 we have already found out here, so this is hv2 minus v0, right? We get this thing here. Now just in case if they ask you stoppage potential, although it's not asked you in the in this particular sum, but since we've done the sum, I'll just show you that in this sum, if they ask you to find out the stoppage potential, you will say that here you will get the value of max Ke. Let us assume that this is extra I'm doing, guys, that Vs be the stoppage potential. If Vs is the stoppage potential, then stoppage potential is given by the formula Ke max max kinetic energy 2 is stoppage potential into charge on electron. We already know the charge on electron, where I can say that charge on electron is 1.6 into 10 raised to minus 19 coulombs. So that will also give you the stoppage potential. Fine, do you get this thing here? The answer for this sum is max Ke2 is going to be 6.16 into 10 raised to minus 20 joules, and stoppage potential should be 0.385 volts. Next, take on next one please. Take on next one please. A light of wavelength 3333 Armstrong units is incident on a metal having work function. A light of wavelength 3333 Armstrong unit is incident on a metal having work function 2 electron volts. What is the stoppage potential of the metal? What is the stoppage potential of the metal? Now, let's find out first the frequency. How do you find out frequency? Frequency of the incident light is C upon lambda, velocity of light in here, upon wavelength, where we know that C is equal to 3 into 10 raised to 8 meters per second. Wavelength of light is given to you, right? Now, let's find out max KE. Max KE is nothing but HV minus work function, which is nothing but HV minus work function is given to you. So I need not substitute that value. So I'll come to know my max KE. V I know H, where I can say that H is Planck's constant, that is 6.63 into 10 raised to minus 34 joule second. So I'll come to know my max KE. Once you come to know max KE, then you can find out stoppage potential. I can say that also max KE is equal to stoppage potential into charge on electron. Therefore, I can say stoppage potential is max KE upon the charge on electron. Right? Do we get this thing here? Now, in this case, you should get the answer for this to be, you will get this answer to be stoppage potential will be 1.729 volts. Fine. Next, take on next one please. The current in a photoelectric cell. The current in a photoelectric cell can be reduced to 0 by a potential of 1.8 volts when a light of 2200 Armstrong units, when a light of 2200 Armstrong units is incident. Find the work function. Now guys, I can say that max kinetic energy is equal to nothing but HV minus work function, right? I can also say that max kinetic energy is stoppage potential into the charge on electron. Therefore, I can say that stoppage potential into charge on electron is HV minus work function, right? Now, D can be written as C upon lambda. What have they asked you to find out? They have asked you to find out work function. Okay. So I can therefore say that Vs into E is H C upon lambda minus work function. Therefore I can say that work function is hc upon lambda minus Vs into E. Work function is Planck's constant into velocity of light upon wavelength of light minus stoppage potential into charge on electron, where you should know that velocity of light in air is 3 into 10 raised to 8 meters per second. Planck's constant is 6.63 into 10 raised to minus 34 joules second. Charge on electron is 1.6 into 10 raised to minus 19 coulombs. Right? Substitute the values, you should get the answer. Answer for this sum should be 6.161 into 10 raised to minus 19 joules. Next, take on next one please. A photoelectric work function is 2 electron volt when the emitter is irradiated with a monochromatic light of certain wavelength. The stoppage potential is 1.5 volts. Find the wavelength. When the photoelectric emitter is irradiated with a monochromatic light of certain wavelength, the stoppage potential is 1.5 volts. Find the wavelength. Similar to the previous sum guys, I can say that max kinetic energy is equal to hv minus work function. I can also say that max kinetic energy is stoppage potential into charge on electron. Therefore, I can say that stoppage potential into charge on electron is hv minus w0. Now, V can be written as C upon lambda. So, I can say stoppage potential into charge on electron is equal to hc upon lambda minus w0. Take w0 on the other side. So, w0 plus Vs into E is hc upon lambda. They have asked me to find out, what have they asked you to find out? Determine the wavelength of incident light. Lambda is going to be hc upon w0 plus Vs into E. Wavelength of light is Planck's constant into velocity of light upon work function into stoppage potential, work function plus stoppage potential into charge on electron, where you should know that H is 6.63 into 10 raised to minus 34 joules second, C is 3 into 10 raised to 8 meters per second, and E is 1.6 into 10 raised to minus 19 coulombs. Right? When you substitute these values, you should get the value of lambda. Answer should be 3551 Armstrong units. Right? Take on next one guys. Last sum to finish the chapter. Light of wavelength 2 into 10 raised to minus 7 meters is incident stoppage potential is 2 volts. Find the threshold wavelength. Find the threshold wavelength. That's it. Now guys, I can say that max kinetic energy is equal to HV minus W0. I can also say that max kinetic energy is stoppage potential into charge on electron. Therefore, stoppage potential into charge on electron is equal to HV minus W0. Right? They've asked you to find out threshold wavelength. So I can say Vs into E is H. Threshold frequency is nothing but C upon lambda V0. Sorry, W0 is HV0. Work function is Planck's constant into threshold frequency. I can therefore say Vs into E is Hc upon lambda minus H. V0 is C upon lambda 0. Right? So in that case I can say Vs into E is Hc 1 upon lambda minus 1 upon lambda 0. Therefore Vs into E upon Hc is 1 upon lambda minus 1 upon lambda 0. Lambda 0 is the only unknown there because we know that charge on electron is 1.6 into 10 raised to minus 19 coulombs. H is equal to 6.63 into 10 raised to minus 34 joule second, and C is 3 into 10 raised to 8 meters per second. Right? Stoppage potential is given to you, wavelength of light is given to you. You can easily find out the threshold wavelength. When you solve this, you should get this answer as 2949 Armstrong units. Right? That finishes the chapter. We'll stop this here for the day. Thank you very much.